Okay. Now, to start with, do you know sometimes in supermarkets you sometimes see a notice on the shelf saying product recall? Do you know this product recall? Or car recall? When there's something wrong with the car, they have to take it back. Or there's something wrong with the food, they have to take it back. I have to do a maths recall. Something, a small thing. Do you remember this here? What was the order I told you to go in? C, B, A, and D. And D. Here is the correction. Here's the adjustment. It should have been B, C, A, D. Or, hey, there's another one you could have used which gives you the same answer, which is maybe easier to remember, which also works. A, B, C, D. Do you understand what I'm saying? I gave you the wrong order. I told you C, B, A, D, where it should be B, C, A, D, or A, B, C, D. Probably A, B, C, D is the easiest one to now remember. I kind of knew deep down that there was something wrong. If you remember at the end of one of the classes I did something which I told you to forget about. Yeah, so deep down I knew there was something wrong. I just didn't want to face it. So anyways, here it is now. B, C, A, D or A, B, C, D. No, this is product recall first, and then we'll start the lesson. And we have tutorial later today. We have a tutorial later today. Yeah, some of us do. So I can give you the worksheet, or I can give you the notes for that as well. I think I can say it somewhere. Okay. Now, can you take out your last worksheet, because we only done half of this last time, the proper partial fractions. So we've done A, B, and C, which is linear over quadratic. Now time to look at cubic. Just change the order. Everything is the same except the order you go in is different. So for example, C still moves to the left and the right, B still expands or contracts, A still expands or contracts, and D still moves up or down. But you remember the questions where I say, describe what this transformation does. Remember those? The order now has to be BCAD or ABCD. What's wrong? No, what's the question here? Yes, because ABCD is easier to remember. That's the reason why. Okay, I can move on. Product has been recalled. Okay, good stuff. Now, if you look now at your proper partial fractions, I've done ABC. Now time to look at D, which is linear over, well, constant over cubic. So again, again, you want to write this as 3 simpler fractions. Good news is, it's not really expected that you solve this cubic by using long division like you did in semester 1. So here it's acceptable to use our calculator to get us the 3 factors of this cubic. So mode 54 does that. So 512, 1088, 632, 63. So my first factor, come on Faisal, is 8x plus 1. Then my second factor is 8x plus 7. And then my last factor is 8x plus 9 all over 48 equals A over 8x plus 1 plus B over 8x plus 7 plus C over 8x plus 9. That's a 7 there. Okay, you know the deal now. We use our trick like before. We multiply everything by this denominator. So now we get 48 equals A times 8x plus 7 times 8x plus 9 plus B times 8x plus 1 times 8x plus 9 plus C, and then if I can squeeze that in, times 8x plus 1, 8x plus 7. Yeah. And this is where using the method I don't like really saves a lot of time. So if you look at those 3, I'll highlight in yellow. If you look here, this one has 8x plus 7 in it, and this one has 8x plus 7 in it. So maybe if I stick to yellow for the same color. So if I said now, can you see that? No. Okay, if I said let x equal minus 7 over 8, what would happen to those 2 yellow terms? Yeah, so in fact, then it simplifies all down to just this. 48 equals B, and then those 2 numbers there. So let's get those there. Minus 7. Well, minus 7 over, we can do this in our heads. Minus 7 over 8 times 8 is minus 7, plus 1 is minus 6. And then the same thing here, 8 times minus 7 over 8 is minus 7, plus 9, 2. So that's 12. So I think B is minus 4 then. Would that be right? Yeah. So there's our first answer. B equals minus 4. For which question though? Oh, D.
Yeah.
Oh, did you get the right answer?
Yeah.
So it feels good, doesn't it? So that's why you have this expression right now of Stephen. But if it makes it feel better, Hassan, you're doing it the way I like.
Yeah, but after 25 minutes.
But I like this way. Yes, in the exam, I'll just have to accept. Probably better doing it this way because it's quicker. Okay.
Why did you choose 7x, minus 700?
To cancel the yellow parts.
Why didn't you choose 8x plus
That's what I'll do next. So if I look at now 8x plus 9. So if I say let x equal minus 9 over 8. Oops, fix my 8s. What happened to the red pieces? They'll go as well. So let's see, again, C bracket, so minus 9 over 8 times 8 is minus 9, plus 1 is minus 8, and then 8 times minus 9 over 8 is minus 9, plus 7 is minus 2, that's a 16. What's that, 3 times? Yeah, 3 times with a positive. So here we get C equals 3. What's left to get now? A, isn't it? Yeah. So, no surprises here. I should say ax plus 1, I want to make that 0, so I should say x equals minus 1 over 8. So now again, let x equal minus 1 over 8. So now I get 48 equals, they're gone, a bracket, so that'll be 6 and then an 8, right? No, hang on. Was that a 9 there? I can't see with my red. Is that a 9?
Yeah.
So if it's minus 1 over 8, that's an 8, yeah, and then that's a 6. Oh, I think A is just going to be 1 then. Yeah. So A is 1. Oh, hurry up, Sayun. Okay. Got my A, B, and C. So I can go back to the top and say this equals 1 over 8x plus 1 minus 4 over 8x plus 7, and then 3 at the end, plus 3 over 8x plus 9. Okay. Go up. But that's this question.
No, the last part.
But that's the very top.
Yeah.
And that's the very bottom. So where do you want me to go?
Oh,
To the very top?
yeah.
Okay. One, two, three, four, five, 6, 7. So we're missing Brandon, Abanoob, Reem, other people too. Oh, okay, just right, can I go to another example now? Do you have that? Yep, okay. So just to recap, we have A, B, and C, and D done. Can you all look at, you all have this still, right? Yeah. So if you look here, we have A, B, C, D done. Now how is E different to D? How's E different to D? The numerator, what's different to the numerator? Yeah, it's linear instead of a constant. That's okay, it's still done exactly like how I just did it, okay? And then what about F? It's a quadratic, and in fact, still exactly the same. The same goes for G and H. No, not for H. H, I, and J will be different. Now they look the same, but the reason they work out differently is because the cubic doesn't have 3 solutions. Now you can't tell that from looking at it. So A to G, I've really done. I've done A, B, C, D for you. E, F, G are the same as D, so it's just H, I, and J left to do as different examples. So I'm going to do H now. So h now, 16 x squared plus 65x plus 18 all over minus, 28 x cubed plus 36x squared plus 15x plus 2 equals, we don't know. So let's have a look at what that cubic could be at the bottom. 28, 36, 15, 2. Seven x plus 2 is one answer. 2x plus 1 is the other answer. And then that's it. So that means one of those answers is repeated. Now I'm not deleting it, I'm just moving it down here to make more space. So that one there and that one there. My calculator gave me only two answers. One of the answers is repeated. That means one of these answers is squared. It has a power on it. So the question is, who can spot this? Does the 2 go here or does it go here? Can anybody see where it goes? Which one? The second one. Why though? Very. I think that's fine, but I was thinking of an even easier reason. If you look at the last term here, what is it? 2. So if I square this, I'll get a 4 times 1 at the end, which is 4. Which is no good. But if I square this, I'll get a 1 times 2, which is exactly that. So in fact, just by examining the last term, it can tell you where the square needs to go. So the square needs to go on that one. Now actually, I'm going to write this again, but more to the left because I need more space here. So you don't need to rub out anything. Can someone just read out those two factors again to me? Alright, what was the first one?
7x plus 2.
7x plus 2 and then
2x plus 1.
squared all over 16x squared plus 65x plus 18. Now, again, A, B, whoops, and C. First one, good. But what happens when you have a repeated factor? Keep one the same, and then the other one's squared. But something a little different happens here. It's not actually C here. It's actually CX plus D. Now what is so different to this one compared to the other ones? Well, I don't think I have it here. No. Oh well, I can show you with this. These are all linear denominators. The numerator has to be 1 degree lower. So if it's linear, then this has to be constant. It's normally the case. Here, linear, so constant. Here, linear, so constant. Here, quadratic, and so this one here should be linear. Although, most of the time, the C actually will be 0. Not all of the time, but most of the time. So if you want to be safe, you can make this one here linear. Yeah, I don't think there's much more to say about that. In my previous examples, this hasn't happened. But now, I'm going to include this in. But I think in this answer, anyway, C again will be 0. Okay? So if you want to make it as general as possible, the top should be 1 degree lower than the bottom. Okay? So we use our trick again. A 2x plus 1 squared plus B 2x plus 1, run out of space, 7x plus 2 plus C 7x plus 2.
Isn't A 2x plus 1 cubed?
No, because when I'm multiplying each of these three by this here, so when this one multiplies the top here, the 7x plus 2 cancels the 7x plus 2, leaving just this one here. Okay, what should I choose first for my x? Not that it really matters too much, the order here. Oh, sorry. Thanks, Faisal. Cx plus d. Okay. What should I do first for x? I think maybe minus 2 over 7. So what do I get on the left? 16. Actually, maybe somebody with a calculator can put the x in here, minus 2 over 7. So, Hassan, do you have your calculator? And Kurdi, you can be backup. Make sure you get the same answer. So, put x is minus 2 over 7. Over here, if I put in x is minus 2 over 7, that goes, and I'm left with this. So, minus 2 over 7 times 2 plus 1 squared. So on the right I get 9 over 49a, and the other two cancel. And what do I get on the left here?
36 over 49.
Great, 36 over 49 or 7? Oh guys, why couldn't you have gotten the same answer?
49.
49.
Alright, 2 to 1, sorry. So, that gives me A equals 4. I'll write that in red. A equals 4. Okay, so I've got the A. What about let x equal minus 1 over 2? Because then that goes, not really goes. Yeah, I need to say let x equal minus 1 over 2. So therefore, so again, Hassan and Kurdi, using your best calculator skills, tell me what you get on the left when x equals minus a half. And on the right, that's gone. And I get cx plus d. Times 7 plus 2. So on the right I get that, and then on the left
Minus 21 over 2.
minus
21 over 2.
21 over 2 equals.
Minus 45 over.
No, minus 21.
Curdy, do you know what you're doing?
Yes.
No, I don't want to look at it. Right, so now if I cancel those, I get 7 equals cx plus d. Now, in fact, it's actually convenient here to switch back to the other method for a moment, because I can now look at this and say 0x plus 7 equals cx plus d. So I actually have two answers here. What's my c? Come on. 0. And what's my d?
7.
And remember, I promised you earlier that the c usually cancels, and you can see there it is as 0. So I got a, c, and d. Now all that's left to get is b. So the easiest thing to do to get the b is, well, we know A, we know C, we know D, so what could I do to get the B here? I just make x equal to anything, so what would be the easiest one? 0 or 1, yeah. So I get let x equal 0, and I get 18 equals 1 times A, so that's just A. That would be 1, and that would be 2, so that would be plus 2B. That's 0, so that's gone. D is, what was D? 7. 7 times 2, 14 at the end. So that's just me making x equal to 0.
18 or 8?
I think it was an 18, because if I put x equals 0 on the left, it'd be 18. 18 minus 4 minus 14. B is also 0. Oh yeah, okay. Yep. B is 0 also. Okay. So B is 0, C is 0, A is 4, and D is 7. I'll go back to this in a minute. So if I just go back up to the top here, A is 4. Oh, that's ugly. A is 4, B is 0, C is 0, and D is 7. Okay. Well, unless you need me to go up to the top.
Could you just scroll down?
This is this. Oh, yeah, okay.
Can you scroll up for a second?
How far? To the start?
Yeah, no, that's it.
By the way, how would you integrate this? What would you do here?
O equals to x plus
Yep, and here?
b squared.
Here? In fact, here is also u equals 2x plus 1 power squared. Because in fact, this is really just like 7 times 2x plus 1 to the power of minus 2. So you let u equal to this piece here. You've seen this before, except the difference maybe is when I did it in class, I could have done a big power here instead of a negative power, like maybe 12, for example. So it's the same thing. It's only really a problem when it will be, for example, if this was a 7x here, then you have a problem. Scroll down to the bottom. Too far? Yep. Okay, next one, in a moment now, I'll do I and then J. City? Do you mind waking Joseph up there? I've lost your interest, Joseph. Smart move. Okay, can I go to the next example now? Okay. So now at I said. Whoops, sorry, I'm mixing them up. 6x squared plus 15x plus 45. Then in the denominator, minus 3x cubed minus 13x squared minus 28x minus 8. Now let's have a look at the denominator solution. Minus 3, minus 13, minus 28, minus 8. And if you look at the bottom, you get 3x plus 1, and then problem. Only one answer, not two answers. Of course, there has to be something else here that multiplies this to make that. So what does this multiply? What type of thing goes here so that when multiplied by 3x plus 1 makes that there? Like, what's it called here? What do you think goes here? No, my question, what type of thing goes here? Linear, quadratic, or cubic? A quadratic goes here, yeah. Will this quadratic have factors? No, because this has only one solution. So this is a situation where you have one solution and then a quadratic with no solutions. How can we find that other solution? Well, bad news is the only way to find it is long division. But I don't think it will take us too long to do. We should all be experts at this now. Alright, so what we got here? Minus 3x squared, so that's, no 3 there. Minus x squared, so that's minus 3x cubed. Minus x squared, subtracting, that's minus 12x squared, minus 28x minus 8. Minus 4x, so that's minus 12x squared minus 4x. That'll be minus 24x minus 8. So 8 minus 8 then, isn't it? And there we go. So that's the quadratic there at the top. So then we say this equals a over 3x plus 1. And then there's only one other piece, which is the quadratic. Minus x squared minus 4x minus 8. But who feels they can tell me what goes on the top here? Bx plus c. Very good. Okay. So again, multiplying through by this denominator, and you'll get 6x squared plus 15x plus 45 equals a times minus x squared minus 4x minus 8 plus bx plus c times 3x plus 1. Just got it there. Write that again so you can see it a bit better. That's 3x plus 1. Okay. My x's look like brackets. It's an x. Okay. What do you think our first choice should be for x? Yeah, very good. Let x equal minus 1 over 3. So Hassan and I suppose Curdy, here's your chance to prove you can use a calculator. Put it in here. So x equals minus 1 over 3. On the right, that will go Then here on the right, I get minus 61 over 9a, and then on the left,
122 over 3.
you redeemed yourself, Purdy, well done. Right, so 122 over 3 divided by negative 61 over 9. So that's nice and neat. You get a equals minus 6 from that.
Sure, that's 122.
We said 122 over 3.
Yes.
Sorry, that's an ugly 3. There. How can I go about getting, or what should I do for the next term? See, the problem is, there is no choice of x that will make this 0. Who can tell me why that is? What? No?
It doesn't.
Yes?
But that's not solution.
Yeah, but why do I know that?
But that doesn't have solution for you.
Yeah, it has no solution, so there's no choice of x I can make that will make this 0. So what would be my easiest choice of x I can make next now? I can choose x to be 0, so I get 45 equals minus 8a, which is actually, what's that? That's a minus 6 now. Minus 8 times minus 6 plus c times 1. Oh, actually, that works out nice because that does give me the c. So, what you got there? 45 minus that. I got c equals minus 3. Good, okay. What could I do now to get my final value, which is b? What could I choose for x now? There's no nice values left, so I can't choose anything that cancels. So what would we choose for x? I think 1 would just be the easiest thing now. Whoops. Let x equal 1. So you get, what's that, 15 for 50, 66? Isn't that right? 45, 50, 66. Minus 8 minus 4, that's minus 12. Minus 1 is minus 13. And then 13 times the 6. Okay, so that's equal to 78 plus x minus 3. I lost my b. That should be bx. Bx. Minus 3 because that's the c, and then x is 1, so that's a 4 at the end. Okay. What am I doing, bx? X is, so just b. Alright. Let's see what we get here. 66 minus 78 divided by 4 plus 3. So here I got b is 0. So, also the b, which is on the x, is 0 here. So the a is, what was the a? Minus 6. The b is 0, and then the c is, what was the c? Minus 3. Well, there's a minus in everything here, so if you wanted to, you could cancel all those minuses. Anyways, I'll just leave it there for you to write. So I'm going to tell you, when you put the x equal 1,
Is minus x squared minus 4x. How did it come out with 13?
when x is 1, you get minus 1, minus 4, minus 8, which is minus 13.
Include the minus with the minus 1 squared. When
You make an x equal 1, yes?
yeah, but
So what's 1 squared?
it's to be minus minus 1 squared, or?
No, it's 1 squared because x is 1. Yeah? Yeah.
So when
Continue? I don't know. What?
if b is 0, does it cancel the x?
You're right, it does. So that's why there's no x here, because it's 0x. So it did cancel it. Right? Yeah? In J, it's the same as I, except the B is not 0. So no difference. Same process, same steps, except you don't get a B equals 0. I often find in the exam, guys listen, I often find in the exam B is usually 0 or sometimes C is usually 0. It's unusual for them to give you a question where you get a BX and a C in the top here where both of them are not 0. One of them usually is 0 and you don't know which when you start. So you have to consider BX plus C. Now, if you got an answer for B and C, that doesn't mean it's wrong in the exam. I'm just saying they usually make one of them 0. Not always, but usually. Okay? And then the other thing which is nice for you to know is they also usually tell you, whoops, what the factors are here in the question. So you don't actually have to do the long division. Now again, not always, but they usually tell you this. So for example, out of the 12 exams where this came up, I think in 11 of them they gave you the factors and in one of them they didn't. Okay, so yes, usually yes, but not always.
Bx plus c, only we have one solution.
The bx plus c is when the denominator is quadratic. And in this case it happened because you had only one solution, so the other part was quadratic, yeah. So, can I just go to a new page? Yeah. So maybe just to recap all our little skills we put together. You start off with a polynomial over a polynomial, and which one has the bigger power? The denominator has the bigger power. So what you do is you change this into a polynomial over factors. And then you say, this is A over the first one, plus B over the second one, plus C over the third one. If the factors repeat, like for example, you get a square here, for example, it's A over the first one, B over the second one, and then you put the last one in squared, and the top here would have to be Cx plus D, because it needs to be a smaller power than this. But sometimes you might get polynomial over a quadratic here, and this quadratic has no solutions. So it's A over the first one, plus you have the quadratic next, and again it's going to be linear, bx plus c. This needs to be one power less than this. So all of these are linear here. Linears, linear, linear. Linear squared, which is quadratic, linear, 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 like that. So although I did quite a few examples, and they might look a bit different, really it comes down to 3 situations. 1 cubic solution, 2 or 3. Now I haven't actually done quadratic. So for example, you can sometimes get a polynomial over a quadratic squared. What would that be? That'd be A over the first one, plus, really it should be bx plus c over the second one. Although, in my examples here, I made the b to be 0. It's usually 0, but it doesn't have to be 0. So again, like with the cubics, you need this to be 1 power lower than the denominator. And the last one, which I didn't write down, which is probably the easiest one, which is a polynomial over a linear by a linear. So that would be a over linear plus b over linear, but that's kind of the basic case. So there's really 5 situations now, I guess. Your quadratic that has 1 solution, or your quadratic that has 2 solutions. Your cubic that has 3 solutions, your cubic that has 2 solutions, and your cubic that has 1 solution. So in fact, it's the denominator that tells you exactly what's going to happen. So it all comes down to the denominator. So the denominator can be a quadratic with 1 or 2 solutions, and then it could be a cubic with 1, 2, or 3 solutions. Do you think it's possible to get a quadratic with no solutions? No, because then you can't factorize it, so that's an impossible case. And is it possible to get a cubic with no solutions? Any ideas? Why not? Say again?
We need a solution.
Well, true. But is it possible to get a cubic without a solution? And you're right, we do need a solution, but could we get a cubic without a solution? The answer is no. If you remember, a cubic always has at least 1 solution. Okay? So once you have a cubic, you are guaranteed that you can at least simplify it a little bit. Although once you have a quadratic, you need there to be 1 or 2 solutions in the denominator. Okay? I think that's pretty exhaustive now on that worksheet. So what I'm going to do is stop, give you time to try some of these, and then we'll go on to the next one.